Today we will use the second-order analysis to account for the effects of deformation on the structural behavior of a system. Long columns can exhibit nonlinear behavior under load, especially when they are close to their buckling limit. Second-order analysis incorporates these nonlinearities, providing a more realistic picture of how the column will behave under various load conditions. Also, at the end of this example, we will compare the results with that obtained from Etabs. A column is loaded as shown. It was taken from a non-sway system, so no transition is allowed at the top and at the bottom of the column. Based on its length and section, we will check if the column was short or long using this question. For a column with both ends bent, the ends can rotate freely and don't resist moments. The effective length factor K is typically 1 for this condition. This means the length of the column is considered as S. The radius of gyration denotes as R. The radius of gyration denotes as R is a measure used to quantify the distribution of a column's cross-sectional area relative to its central axis. We can calculate it using this equation. Also, the code allows us to take it 0.3 times the depth. For bent columns, M1 and M2 are generally 0 because the bent supports don't resist moments. Since the slenderness ratio is high, the effect of slenderness must be included. When P is applied to a cylinder column, the moment at any point increases by an amount equal to the P times its lever arm. Then the maximum bending moment due to simultaneous action of flexure and axial force will be. It can be shown this summation can be rewritten in the following multiplication. The SM represents the difference between a column that has single curvature and a column that has double curvature, and it can be obtained as shown. For braced frames, and since the forces are applied perpendicular to the axis of a structural member, SM equals 1. The load at which a column will be buckled or fill due to instability. Finally, the second-order moment equals to the mid-span moment times the magnification factor, which equals to 62.25 kN meter. Now we will move to the Etabs to check the results.